Ну ладно, давайте начинать.
Okay, let's start. So what's going to be our topic today? Postgres is famous for its procedural languages. There are a lot of them, and they are part of its extension. You can write your own language if you want. A small overview. There are 4 languages in the box. PL, PGConf, SQL-like procedural language, which is out of our view today because it's too classical, too simple. And PL, Perl PL, Python are languages built based on quite popular languages of programming. PLTCL, it's probably a tribute to history. Not many people program on it, but still I had Win users who asked us to set up PLTCL for Windows. He wrote something on it. I haven't met any other people with this, so we're not going to consider it, although there are other languages which are not in the box, officially not supported by the community, but they have their authors, maintainers, and supported by them. PLv8 first, the programming language is based on JavaScript, which is basically the JavaScript, which is very well supported and quite popular. PL Java, also alive, but less popular to the number of reasons. We will discuss them later. PLR, another language mentioned in an article posted on Habra recently. It is something for statistics. It's a very special thing, and I'm not going to tell you about it because I don't know much about it. PL Ruby also, but it is all desolated. PL PHP not designed anymore, not developed anymore, not many users. And Ruby also not very popular, although it's quite progressive. Although there are such languages as Go, Lua, which are scripted and which are used and are developed, a lot of commits. And there will be references in my presentation on these languages. You can check it. I haven't tried them yet because I didn't need it. Maybe after some time I will try it, and let's see. Maybe it's really useful. PL Shell, another exotic language, which is also present in reps, and you can find them there. Red Hat reps and Ubuntu. You can find setups based on PL Shell. I don't know the real reason, but there is some instances, such zoo we have here. If we take out of the box, they are normally installed from packages, and many languages not in the boxes are present in packages. I have Ubuntu on desktop, and I install it like this. PL Perl, PL Python 11, PL Python 3, another language different from the second one. It is being installed. PL V8, no setup still for V8, only for V10, non-official for Postgres 11 without warranty. Maybe you'll be lucky and it will work. If you have CentOS, there are less. For core Python 3, maybe a little bit more. For CentOS, in rep you'll find only PL1 and PL Python conventional. And after you install it, to make your DB work and to make it work in the DB, you have to execute create extension. Please pay attention. There is a U letter in the end. PL Python, PL IPython U language. What does it mean? PL and U, we will discuss it later. Many of you maybe know. If you want to make it manually, it can be done easily. In Postgres, it's done like this. If you want to have Python 3, you should indicate they do not combine. They're not combined together with the second one, so they should be assembled separately. But if you want to have PLv8 just with your hands, so that could be a great heroic deed, and if you succeed, you should write about it on hubs, because to assemble this thing, you need to assemble the whole PLv8. You should but not you, but when you're going to type in make, a few gig will be received on your machine with the whole setup of the Chromium. It will work, and it would be good if it's going to be assembled. Not in all cases I succeeded, but from time to time it changes depending on different versions. Maybe you will succeed. I succeeded several times. There are two options, static and dynamic. Static, it is inside, and dynamic, it is used from your system, if it finds one. Okay, if we now know how to install it, let's discuss classification of our zoo. There could be normal languages and other than normal. Normal, which we're going to discuss now, and most probably most useful ones, PL/PG, SQL, just for the sake of comparison, PL Python, we're going to discuss them, because PL/V8, because we're going to study them, and some others. We will mention them, but we're not going to study because of different difficulties. Quite specific languages, we know one of them is PL proxy, which is necessary to organize proxying and distribution of loads between different servers. Quite a specific thing, we're not discussing it. PL SQL language, it's normal or not normal, whatever, but still he is a little bit aside. Do not confuse it with PL/PG. You should understand in Postgres, unlike Oracle, there is an opportunity to use procedural, not only procedural, but SQL language for storage. PL SQL, it's normal SQL, you can write functions on, and another language, C, which can be also used for writing functions. We do not consider it because it's not normal in the context of our today's masterclass. Several times we carried out some contests on high loads. We make queries and surveys. The question was, what procedural language is the fastest one? And people told us you should use C. C or PL SQL is the fastest. Why? PL SQL can be faster than C because it can all what is written can be optimized and be inlined and faster. Under what conditions can it be inline? It is written in the documentation, but it shouldn't be a security definer. Briefly speaking, it should contain a simple SQL query without details and for different conditions. The majority of SQL functions, it's just being inlined. So PL SQL language very often can be faster than PL/PG and even C if you will try to write simple SQL request on C. So let's speak about normal languages now. We should remember standards. SQL is the language which is in compliance with the standard, and the DBMS producers are complying with it. And what about procedural languages? There are also standards for these languages, SQL PSM and SQL GRT. These are two standards. PSM is a procedural language like PL/PG SQL. This is a language which is similar to IBM DB2 procedural language, less similar to MySQL. Well, but it's quite far from Postgres language, although conceptually close. And there was an attempt to implement it a few years ago. PL/PG is on GitHub still. You can see the correspondence, but no one uses it because why? Another similar language is needed. So it's not very good with standardization. The other DBMS producers like Oracle and Microsoft, they just spit on, forget about SQL PSM and do not want to abide by this standard. GRT is a standard for Java procedures, and PL Java complies with this standard especially. There are a lot of languages, and what if someone is still not enough? It's a big undeveloped field. It's not the fact that we need to map languages to Postgres. It's a domain-specific field of languages. And it's possible to write a language here for a specific task. There's one limitation. Your language should be written only on C, a handler, and to determine the language you could write from 1 to 3 handlers on this language. To interpret the function, second, if you want to have nameless blocks, the handler for such blocks should be written also, and if you want during UL code creation function to validate it, you need to write the validation function too. But you will, with one function will be enough here. And there are also good examples. Pure Perl is the most readable one, and it also contains around 100 kilobytes of code, not so much. So I ask you all to write more languages, and it would be a great job if you make a framework to write it not on C, but on some of the existing languages. For example, Python or Perl. Like foreign data wrappers can be written on Python. Maybe it would be good if languages could be written on Python too. Now about ULET, they could be trusted or not trusted, untrusted languages. What is trusted language? It's a language which can be trusted to a simple user without the risk of damage. It's the language which is not allowed to work with system functions, with I/O and reading. To make the language trusted, the interpreter should support the following limitations. If it doesn't, such language couldn't be trusted. Such languages are available to every user in Postgres. Untrusted languages, these languages without any limitations, Postgres allows it only for super users. Super user can create something using this language for the reasons of security and safety. Well, let's take a look at the use of these languages. PL Perl can be both trusted and trusted because interpreter of the Perl can limit it, and Python cannot limit it, so it's only untrusted. V8 only trusted, the other way around, and Java also both, can be both. How can we compare when to take PL PGSQL or other languages? What is special about other languages which we can't find with PL PGSQL? There are more comparisons, of course, and we're going to come back to these comparisons while discussing it. PL PGSQL embedded language works with the data types from Postgres. The whole variety of data is supported on a native basis. If we work with a procedural language with another interpreter, these types of data should be mapped somehow. They will come there in a text form or in another ugly form. It wouldn't be comfortable. But if you are untrusted language, you can send a letter from there or ping someone in the net or visit a next door page or make an HTTP statement, whatever. So there is a difference between these languages. Now let's move on. Some operations in PL PGSQL might be too expensive due to the fact that all these subclass types are supported, and to add to integral parts, you should first decide how to do it, how to add them up, and only afterwards get this sum. And it's sometimes very lengthy process. What are the features of all these procedural languages and how do they work with the database? In Postgres, there is a special SPI interface, server programming interface. It's a set of functions which is available for extension writers, C writers, and all these PL languages provide its wrapping, its shell. It's different. In every case, you can connect through the network, but it's of no use for your local database. It would be another backend. You can visit next door databases using PsychoPG or normal DBI. they have their own memory management. You should control manage, especially in terms of garbage collection. They have data structures which should be transformed in different structures. You should also control handling errors. And let's take a look in more detail. Perl. This is the most usable procedural language which is present in Postgres. This is true. How can we use it? What are the specific features? Of course, there is an interpreter. It's a big superstructure in the memory, but it is created only when you start using this language, only in this way. And when it's created, init should be executed. This is the code, the expression which sits in your config file. There's a parameter, a variable, plperl.init, and it should be calculated while downloading the interpreter. Normally, different modules are being uploaded, different calculations done, and there are also options of separate inits for trusted and untrusted Perl, and the different parameters, important parameters. Use strict. Perl without it is just a mess without it. You should include it initially in your config file. That's the better way to do it. If you use two languages, then there should be different interpreter without any magic link.
But apart from that, all the functions in one interpreting, they have one global context. And these variables can be sent through the data from each other, caching it, and the usages on the other one. This is one of the reasons why we use these languages, because they have a global context where you can cache it yourself. PL Python is a little bit different, a little bit contrast, have its own interpreters for the first address to it, and it's in two popular versions, 2 and 3. They have a conflict between these two names. They do not support each other. They cannot be in one process at one and the same time. So if you use Python 2 and then you call up with Python 3, the interpreter will die. Backend will die. So we need to reconnect and start all over again. This is the fatal arrow. That would be a fatal arrow. In Python, you cannot make do what it has to be done during initiating. For those who likes to do one-liners because of the syntaxes of Python, sometimes it would not be possible to make that one-liner, but the global things are still there. There are two variables, SD and GD, in every function. These are the vocabularies where you cache what you like in one of the functions, and global ones between different functions. PL v8 is a good language. The peculiarities are the following. The first one is that it is trusted and it's standing aside because the Progress Society will not take this wrapper, this huge thing for V8. It's very big. That's the biggest one, the biggest disadvantage of this language. It's only trusted. The good thing about it is that it has automatic mapping into the internal system of via JavaScript for the window functions. This is the only language, plus the sub-transactions. In Python, the same. It has a special interface for the simplified functions to be called out from the same language, and only one language with execution timeout. So you can do it on default. If you do it manually and using these parameters, you can set up this timeout for calling out these parameters. And initialization is very interesting in this case. It's only trusted, so it cannot read the library from the disk, so it cannot upload it from anywhere, only from the base. So in order to set up the initialization, you need to make a function in the same language, put it into the base, and mark it as the parameter for PLV8 startup pros. So we'll talk about it later. Here's the link to the tutorial, very good article where you can learn a lot from. As for the Java, we will not try it. And why will not try it? Because in compilated language, and to use this language, you need to have the whole package to put everything together. So this is quite a long process and lots of writing and programming, which is too much for the masterclass. But in principle, there's some document that you can review, and I never had a big desire to write anything or to implement everything on something on PL Java. The languages that we talked about, it PL V8 and Python is good enough. PL and V8 Python, nothing new in Python. It used to be faster than PL, but now it's not like that anymore. So currently using the PL Python compared to other two languages, there's big advantages. If you use Java, please look how much memory you have, the settings of the memory. And sometimes it is recommended to use the garbage collector, and you need to set it up as well so that it doesn't collect the garbage when it's not needed. So you do not set up the memory; it will eat up all the garbage, and it will take too much into it. For the hello world, the easiest thing to do in the hello world, you can even write it even shorter, and instead of alog note, you can write or die. And this is how you will get the text node, text string or thread. And it's very simple, it's workable, and later we'll have more examples with the more complex text lines. With the Python, there you can see the difference. It is built up based on the internal SPI, but every language is a bit different when using it. For instance, why Python is good to be used, because in this case you can use these messages in Focus. It has different parameters, not just text link. You can get the hint, detail, the number of the line, many things. In Python you can mention those. In other languages it's not possible, only the text line can be mentioned. For each level of logging, you can have different dots like debut, log, info, fatal. If it's arrow, then you will get the transaction. If it's fatal, then you will get the backend opened. And panic, when you will get all the offers. But in Python, it's not being implemented. PLV8 Hello World is the same like in Perl, pretty much the same, but you can send up an exception with a throw, and if you throw the exception, it will also show you the arrow. And PLV8 log with parameter arrow. So all the things are very easy to be done and set up, and it's very easy to start learning the language from. Saving procedures are used in order to work with a base, with database. And so let's see how to work with database. Let's make a query, and with Perl data damper, we see the result of the function here. You see the easiest functions by exact query. The easiest query, it gets the status, the number of the lines, process lines, and the content itself. You see one row, X with the meaning 57. There is different status for the rows. If there is an arrow, that could be different, but depending on the type of the search of the query, the status will also be different. There are some successful statuses for the update, create table. You will have your own statuses for select. Looks like that. There is process rows and the update, and the lines will get the lines, but the rows are not always there. For the updates, they have the returning lines. They have returning. PL Python that looks the same, but it returns not only the structure of the existing objects, but the specific objects that you can work with in different way. And the object is an array, so you will get different lines. So the first line is taken from X, and then we'll get the number or the figure. PL V8 is the analog. It is the same. For us to look at the structure, we use JSON Stringify. This is the library to work with JSON. See here, you can see the simplified structure of the data. This is how we work with searching queries. In all the languages, it's very simple and it looks the same. If you work with the languages, you always want to put a search some bad symbols, like you need to encron them. If you don't do that, then later on you can have a big problems, and sometimes you can get into the scandal. There are some functions in Perl. This is the wrapping SPI functions that are implemented on C, quote in nullable, quote ident, quote literal, quote nullable. You need to screen it as a simple line. This is what will happen if you do it like that. The apostrophe has to be doubled, and if you open the brackets, there are some additional functions which only exist in PL Perl for the arrays. For by A, there is a special function, and also function typed literal, which is a very good function, and the meaning of it is that any type, it doesn't matter, it will escape it in a correct way. So the line array will be escaped by this function in a very good way. In PODAS there are many of them, so it doesn't know each and one of them, but if you try time range, it will get surprised because it knows nothing about it, only in the form of the text, so there is nothing to escape it. In Python, it's not a surprise, but the same functions are listed, and they're running the same way. The additional could be SPI. Function, do we have that in PL V8, do you think? The same functions? Yes, we do. How can we not work with those functions if we don't have them? All three languages, they work the same, even to the syntax's peculiarities. For us to have some fun, let's get to the performance and the production. Let's see which ones are faster. It's hard for us to verify, but with the timing in progress, let's say it on our lap, so to say. So maybe someone wants to tell me which language is the fastest one among these three. Perl, you think? Any other opinions? PL V8, so maybe let's vote. No, we are not going to vote, and I'll tell you why. The question is not the easiest one. They could be different, they could be the same in different situations. Comparing to these languages, we'll do the search, the very fast one. It's on my laptop, and the average one would be the fluctuations with a short time. Search, it shows the same, and SQL, PL, SQL, and Perl. They're a little bit slower than SQL, but 40% slower than SQL, but these are additional time that we need to have the same bracket. So in the interpreted language, it's a little bit slow in the beginning because it's uploading, and after some time it will get faster. The Python is a little bit slower. About 2 or 3 years ago, it was faster than Perl, but the current version of Perl runs faster and better than the Python. Well, the results could be the same, that if we compare 0, it is 0 whenever. So it takes more time to make this square, like to write this line. So the difference in the languages can be hardly to see, so let's make something longer. Let's do something 1,000 times. Here you will see the difference between the languages. PGSQL is twice faster than Perl in this case. What do you think will happen to Python? It's pretty much the same, but V8, it's interesting to see that V8 is, the delay of V8 is quite big compared to the previous one. So if we go back 2-3 years earlier, the comparison was different. Both Perl and Python for this year, they became faster. That Perl became much faster than Python. So V8 is a little bit behind in spite of other things, but Perl and Python are running very well. Those who know, the specialists will see that there's something's wrong, because we didn't say that the word the couple. So we need to prepare these queries, we need to make the query plan, and then according to this, make the search. For us to modify, we can use the SPI function, SPI underscore prepare, and make the query, the prepared query, with the rest of the functions that are mentioned here 1,000 times, and then the result we get this thing at PL Perl. And SLG square, we cannot follow these queries. Everything's done automatically, and we believe that it's done quite well. So when we've done that in Perl, PLPG language was reached by us very fast. What was Python? It's the same. If we look at the two figures here for Python 2 and 3, and Python 2, it's 10%, sometimes 20% slower than Python 2. Python 3 will be slower. So V8 is a bit on the same line. It's a little bit slower, but pretty much the same. And all the languages will get the functions for the preparation of the query and then implementation of this query. Please note that we have that function, and you can cache it, and then interpretation of the prepared query, hoping that it's still there, and it will change if you change the structure of the data. But you can use it as much as you like. Let's make some calculation. As we can see that we have all of the language, we are working with the database. We see that performance is the same, so maybe there is the line which there is a limitation. What doesn't work with the database? For instance, if we make the calculation of the 1 million figures, if we make the calculation of the square of the millions, do you think it will light up in PL, this figure? This is this square of the constant, it's a million in a cubic. Then it can fit into one line. So let's make the calculation. The Perl gives us 8 seconds, and PGCL is less. The arithmetic is less faster with Python, and Perl, the calculation is done fast enough, 3.5 faster. So now they make conclusion that if we work with a database, then nothing principle is given can be given by these languages apart from the caching. And if we make lots of calculations, that these languages can give us lots of the advantage compared to PLGSQL. What about PLv8? Here shows the best results. What do you think? Why does it happen? What will happen if we use that language? Will we be in trouble if we use that language for the calculation? Yes, we will. Because the answer will be the following, a very strange one, which is not correct. For those who know, these numbers get lots of zeros in the end. What you do not see, the zeros, that should lose your mathematical intuition, should tell you that something is wrong. So you need to convert this number. And using this touch screen, this number will change. There's an equal number with the 65 numbers, and these are only slots, not the equal numbers.
So we are charged for, unjustly charged for this speed. But it doesn't give it to you. It's unfairness. We've been charged for nothing. It's just a structure like this. Or the script is structured like this. It's done just for calculating the money. Well, cunning people can use a formula for calculation. It will be even faster. And if a developer knows the formula on the Perl, but it doesn't know it for V8, then for the Perl it would go even faster. Okay, you should take it into account because rounding can happen. Now we should discuss memory. It's high time. You remember I mentioned initially you should control it. Each of these languages has some peculiarities of handling memory. Perl doesn't like the fixed structure. If you have a pointer on something which contains the pointer again on something, this is going to hang eternally because the counter will not be zero. This is a Perl, so you should control the destruction of your objects. With the garbage collection languages, they are quite smart. You shouldn't control it, but you can never know when the memory will be released, or will it be released at all. There are other specific things to provide interaction with SPI, with Postgres, because there are structures allocated by SPI, and Perl, unfortunately, doesn't know that they have to be freed up. If you use a SPI exec query, simple query, everything will be okay, no memory used up, automatically will be released. But if you make SPI prepare, it won't die when this variable will go in dollars, because you shouldn't do like this. It's not good. After SPI prepare, you have to make somewhere SPI free plan function. If you don't do this, the memory will grow in an unlimited way. If you use SPI prepare in Perl, you should always do SPI free plan. That's how it goes. Now about Python. What is good about it? It doesn't run, it doesn't leak. Anyway, memory stays fixed. Either it's attached to query or conventional query. Everything's fine there. In V8, it happens like in Perl. If in V8 you're going to execute a simple query, the memory will not run. In SPLPP it will. What should we do to prevent it? Correct, you should revoke SPA free plan. But in V8 it is spec'd in this. It is spec'd like this. Free function. In V8, in general, there are some hints on the object-based orientation, funny ones, but anyway, the prepay result is an object, and in Python and Perl it is not, although it could be done like this, but just the way of thinking is different there. Okay, fine. Functions, it's okay. We considered nameless blocks until now. Now let's handle functions. Functions are differ from these blocks only by the fact that they've got parameters. Although there were people who wanted to make parameters also for nameless blocks, they designed a special patch, but it lays somewhere unused. Let's take a simple function with 4 very interesting types: pink, byte A, the most mysterious one, and JSON. JSON B. Let's take it from the very beginning. I'll explain why. So far, between JSON and JSON B, there's no difference because both will come to this function in a form of a line. Well, I didn't show you what will happen. It will come in a line, and JSON, we would like to turn JSON to a Perl-based structure, but it won't be comfortable to work with this line. Then you will have to invoke a function manually, which will parse it anytime. Just to avoid this, we introduce create transform in Postgres 9.6 version. It was realized first for HStore, not for GSM. What is create transform function? Here you can determine the transforming way of function from Python to the type of data of Postgres and the other way around in order to provide the data exchange between these procedures. Well, in Postgres 9.6 we have realizations for HStore, for PL Perl, and for PL Python languages. It looks as follows. You have to write 2 functions, special functions of special type, one function for one way and the other way for the back transformation. And then you connect transform to them. For this type, for this language, both functions should be used. Just recently we see emerging in Postgres. We see 2 transforms for JSON-B designed by our Russian colleagues for design and for Python. And in this way we should get rid of manual parsing and get the structured parsing already. For this we need to install an extension, and this extension is called JSON-B PL Perl, and then you'll be able to mention the transform form in the list of functions as now. Here we say that JSON-B has to be transmitted in a transformed way. And now JSON-B will get into this function as a structure. The same way works with Python too. If you would write the same function on Python, you will see the output, which is shown here. Look what we've got here. Byte A is turned to a real bytes line. It's a 60. It will be hexadecimal form. In Python it is written better. The byte is being transformed to a byte line. The array is transformed to an array. In Perl it is transformed to a special class object. In Python it is transformed to the array. JSON without transform will also be a line, and as for V8, if you write the same function in V8, So everything will be okay. JSON will come as an object, byte 8 as an arrow of byte, text mass array as the digital one, and booleans and datas, all these time formats will be transformed to JavaScript data. V8 doesn't need transform because it's embedded there. It's all done there in the correct way. So if you work with JSONs, it could be another argument for V8. Now a few words more about these languages. PL, Perl, and PL Python don't have their versions. They have interpreter versions, Postgres versions, but PL V8, since it's a separate piece of code, it has such an attribute as version. It's being evolutioning quite fast. There are some functions which are not included in packages, but well, there are some other versions, and programmers should check versions first. PL8 has version attribute, and it can be used. Next comes another feature with V8. It's an opportunity of fast access of accessing function. A find function which can find any function by name. You can invoke any other function, not using select or SQL, but using find function command, and this command will invoke this function for you. But you need to know only that there will be problems if there are two of such functions. In Postgres functions, there is a polymorphic features, one name but different parameters, but in V8 it's not possible, so it will come with an error if it's a polymorphic function. This is a limitation in this regard. Now about initialization of V8. Remember, in the beginning I showed you a slide and I told you that this language doesn't have a disk worm, so it's not possible to upload a library from the disk. It can take it only from a database. And the easiest way is to write the initialization function. What can be done there? In this function, there is this script which is turned to a context for all V8 functions and blocks. You can determine there some functions, some variables, constants. You can set it there in the following way, by attaching them, assigning them to this internal context. And then you can use them inside your code. If you just write this dot something, this will be then determined. So in the initializer, you can do many other things. You can go into the database, you can upload some data arrays to your cache, well, whatever. But the initializer should be a function. It is quite convenient, because when you work with Perl or Python, and when you upload something from your disk, you should care for versions of this something, and you should take care of it separately from the code which is in your database. When you take the version management, you should think separately about what you install in the libraries and about what is in your database, and you should handle the incompatibility somehow. That's what you've got in the base, and you can switch with only one command the whole version of your code. Just a few more words, just come back a little bit. We discussed prepare, and what prepare has to do with parameters. We need to discuss it as well, because the prepared queries will not be good. You should indicate the following parameters: $, number, and then type of parameters. Prepare wants to get something. If you have dollars, if you want to get the list of parameter types. And so when you execute this SQL prepare, you indicate the value of the parameter. It is quite straightforward and clear, and it is in line with the PL PGSQL. Now, what about Python? The point is the same, just the syntax is different slightly. You have parameter types and values, and Python asks you to pack all these on your own in an array. In all other things, no differences. PL v8, same story, very similar. And in Java, by the way, it's different. If you would use PL Java, there's no SPI. There you need to use JDBC standard to work with the database. And when you work with SPL Java language, some pseudo JDBC connect is built there, and you work with your database in the same way as you would work it from the client application. Seems quite convenient. I don't know why they didn't do it in Python, but maybe it will be done at some stage. Maybe it's a question for those who work with open source. If you want to design specific drivers for Perl and Python, you can do this. Now cursor. By the way, all these functions which we mentioned, exec and what we had there, SPI exec prepare, SPI exec query, all these functions provide also limitations on the number of lines they are returning. They cannot return you too many lines, and if you still want to have many lines, you can't go without a cursor. Cursor allows you to pull them up one by one. You can work with cursors in all these languages. So SQL query in Perl gives you just a cursor, out of which you can fetch lines one by one as soon as you come to an end. In Python, approximately the same. Cursor is an object which can be used in a cycle. It's not necessary to close cursor, by the way. It can be closed on its own, but if you want to reuse it, then you should first close it. For V8, same story, but just don't forget to release the query plan, to free up the query plan. Now transactions. We have a good thing in 11 Postgres. We have procedures now. Previously we had only functions. Now we have procedures inside which we can commit and roll back transactions and work further. So in Perl and Python we already have this support, because for version 11 we already use it. So we have SPI functions commit and rollback, which can be used in the procedure to manage transactions. There are also sub-transactions there, and V8 doesn't have it because I haven't seen a setup for version 11 yet. So what about sub-transactions? There are save points in Perl using which you can depict embedded sub-transactions. It is just a to-do version for Perl, and it has already been done in Python. A sub-transaction can be determined, wrapped up, and you can execute something. As sub-transactions comes down, then we come to an except block. If it doesn't come block, we go to else and move on. A similar thing we have in V8 in a JavaScript syntax. I repeat once again, they didn't do it in Perl, although nothing prevents you from doing this. Okay, now let's come to a finish, and now on the background of everything we mentioned, let's think about purposes, why these languages should be used when we not enough SQL, PL SQL are not enough. So you can see that working with complicated data structures, with algorithm, with trees and parsings, with and writing it on PL PGSQL is in principle possible, but I wouldn't do this. So sometimes you can use a complicated algorithm in working with SQL. For instance, we need to generate SQLs for reporting, for instance, if it's necessary. If it's really a big algorithm, to program it on PL PGSQL is also not so very pleasant, and it may turn out to be very slow. Another reason is a big set of libraries of everything which was realized, and also the possibility of handling C libraries. There are a lot of things on Perl, on Python, and you can use the procedures with the existing libraries. For instance, during migration in Oracle, you see a function of sending a letter, and you start surprising that there's no subfunction there, but still we have a lot of functions. Another reason is working with external data. If you have untrusted languages available, for instance, V8 and Perl and Python can be used here. So you can go somewhere. Normally you would use FDV to enter external data. This is an interface which is not always comfortable, convenient. Here you can go without it. You can ping, you can use mail, ask queries by mail, and so on and so forth. And yes, one more thing. If you want to write something on C and prototype something, you can do it where the speed is optimal.
This is what I wanted to share, and in the end I want to say that it's a good thing, but it can kill everything if you overwork with it. So please follow the steps and be reasonable with using this language. So I can say that always can get better. And Perl, there's lots of things missing, and Python is something's missing. These languages are very popular, but there are other languages like Go and Loan that people work with. So those who want to work with those languages, you're very welcome. We can even discuss what we can do with them. And now it's time for the questions and the answers. Of course, yes. There is no microphone for the question. In every language, there are tools for sharing the memory. So you take a shared memory on the file. You can put it in the file, in the folder, and then storage everything in the file, or shared memory. And the second question is the prepared queries. Are the sources that I used they're the same, or if I use a few interpreters one at the same time, what are the resources? Each of them has its own memory, and each of them storages the data. And of course, there are costs that, there is some structure that is storage, but the function of this interpreter is also. The smallest one is 30 bits. And if you use some algorithms that erase it from the memory, so that for the prepared queries, so it's been divided between the queries of the functions and queries of the client's queries. you should organize these lists of queries and implement or realize the algorithm that you like to be used. So on server, I can use the pool of prepared queries. No, it cannot be used for both of them, but for each pool can be where you can keep the queries, the general ones and the client's queries. That they're not, you cannot unite them, put them all together. The client's queries, if they are wrapped up in their functions, then yes. Any other questions? Its own memory. Its own memory. The operations, not from Postgres. Well, some like to use it, some don't. But because it has to be there, you need to rely on it. That you are talking about the buffers that are shared. This is a work memo. Each process has this something on its own. If one of your processes takes lots of memo, on one of your slides in PL Java, it says that you use ODBC. Was it a mistake? No. It was O. No. It was D. It's misspell. It's JDBC, of course. Yes, thank you. So is it the same transaction? Is it the same sub-queries that are saved? Or you can do it autonomously? If it's autonomous transaction, there's no such a thing as autonomous transaction status. So you can show it, or using the enterprise, it's there. But in Source, there are no autonomous transactions. With the help of background broker, OLP ring, you can visualize them. In your SPE, are there such functions? No, in SPL, there are not autonomous transactions whatsoever. Any more questions? And in V8, do you have the use script or let const or such things like that? No, it's in Perl. Yes, but in JavaScript it also exists. Everything which is in JavaScript, of course, we have that. It's a usual JavaScript, and you can compilate it from with different parameters like timeout, or with syntax as well. I don't know. So let me ask you a question. Have you ever used these languages in practice? Are there such people? With small tasks, yes, we did use these languages. And in general, NPL, SQL, well, yes, all the time. Well, comparison to these two, everyone out of 10 gets to these languages. NPL Perl, that's the easiest one to be reached. But I think in V8 it's also a good language, PL V8. Speaking about the measures, when we ask for SPL Python for the external source for HTTP query, you can also get into trouble with external DCS If it's slow in the framework of one transaction, with one function, you'll spend lots of time. This is true. Everything which is external input and output, you need to set up a timeout. Or in a line, if it's done by batches. It's a different story. Any more questions? If there are no questions, then we have a lunch break. Thank you very much.